Okay, Assalamualaikum. Selamat sejahtera. Alright, so this is actually a continuation for our chapter 3 pertaining the anatomical basis of human motion. So this topic will actually discuss a bit about human locomotion, or we can say that how human move based on anatomical point of view. Okay, let's move on. Okay, so under this topic, we are going to discuss a bit about the locomotor system. So loco is movement, motor will be our muscle lah. Okay, our muscle and skeletal system. And then we are going to discuss on the principle of human locomotion, and also we are going to see a bit about the gait of walking and also the gait of running. Okay, so we start with locomotor system as I have been defined it before. It is actually a combination of movement and also muscle. So the locomotor system is also known as the musculoskeletal system. It is made up of the skeleton, the skeletal muscle, tendon, ligament, joint, cartilage, and also other connective tissue. And when this part works together, it will allow the creation, or it will allow a shape to emerge, and the shape is actually movement. Okay, like what we can see here, we have a skeletal, and then within the skeletal we have the nerve system, the ligament, the tendon, and also finally the muscle itself. All right, move on. We have this is another example. Okay, we have when we talk about locomotor system. Okay, let's go back. It always start with the brain, where it control the movement of the body by sending signal to the spinal cord from a specific region of the brain. So if we try to divide the brain into different segment, we can divide it into four different contexts, where we have the four different loop. Okay, the frontal loop, the parietal loop, and then we have the temporal loop. Okay, so all of this loop responsible for a type or a things, responsible for a sensory, responsible for thinking, and also storing information. Okay, from the brain, all the signal will be sent down through the efferent neuron to the working muscle. And when we see things, let's say we touch a hot things, or we see some obstacle in front, those signal will be sent to the brain through the afferent nerve. Okay, so we have afferent, we have the sensory. Okay, like say our fingers, we have the sensory, and then the sensory will be sent impulse to our brain through afferent nerve, or we call it as we call this as the uh, upper pathway. Okay, upper pathway of the neuron. When it goes to the brain, it will compute and everything. So the final thought or the decision will be made, and then it will be sent down towards the working muscles through the efferent neuron pathway. Okay, so we can see that our brain is actually the central executive of our body. Okay, so the movement can range in scale of from the gross muscle adjustment towards a fine motor movement. Okay, let's say we take this an example. If we talk about gross muscle movement, it will involve large muscle, and most of the time the output is going to be large, yet it is not accurate. And if we take a look at this, let's say this one is more towards the throwing itself. So to ensure that the throw is accurate, control need to be given to the hand and fingers. That will be fine muscle movement. So we have gross muscle movement, fine muscle movement. It will involve movement of the muscles, contraction of the muscles, where it will move or it will affect our joint and then our skeletal, and finally we can see a movement itself. The difference is just a gross movement being started by large muscle group. For example, this one is more towards the abdominis, the quadricep, and also the hamstring, and then towards the throwing itself, where we are going to control much smaller muscle, which is our bicep, tricep, our flexor, and also our extensor digitorum, in order to get a very clean and accurate release. So we are always starting with large muscle group, and then it goes down until the smallest, the tiniest muscle for accuracy. Okay, so this is another definition of gross motor and also fine motor skill, where the gross motor skill can be defined as major body movement and normally associated with strength, endurance, and power, while small or fine motor skill is a movement, okay, that originated from small muscular movement, which include small, precise, and require longer period of time to learn and refine. For example, pitching a baseball with direct end accuracy, or also spinning a bowling ball. Okay, and this is another part of the locomotor system, which is the skeleton. We are going to see skeletal movement after contraction and after the movement of the joint itself, and then only we are going to see skeletal movement, where we can define that as bodily movement. So the skeleton is made up of 206 bones, and the bones can be divided into two categories, which is our axial skeleton and also our appendicular skeleton. So bone are formed of connective tissue reinforced with calcium. So we have two calcium that reinforcing the bone, the calcium carbonate and also the calcium phosphate, where it is abundant at the shaft and also at the cortical level of the bone itself, and also consisting of glycogen and water to ensure that the bone, although it is stiff, it still have some level of flexibility upon it. All right, next one. When we talk about bone, bone also have a softer center called a marrow, where blood cells are made. Okay. Uh, okay. And the main function of skeletal system, it has three basic main function, where the first one is to provide support. Okay. It provide support and also shape of our body. And the second one is to protect, where most of the time the cavity of our body consists of a lot of organ, and to ensure that the cavity is safe enough for the organ, we have bone surrounding it. And finally, with the help of muscles and also joint, bone provide movement, where most skeletal muscle are attached to the bone in opposite working group, like the bicep and tricep, and then when one of the muscle contract, another one will have a retraction. It will move a joint. For the example of the hand movement, it will move the elbow, where we can see flexion of our forearm. So the skeleton also act as a place to store minerals such as calcium and also lipid that we can have abundance in the trabecular parts of the bone itself. Okay, next is skeletal muscles. So we can have, or we can divide that basically into two, which is our skeletal muscle, okay, which is one type of muscle that is involved in voluntary muscular control, and also another one is smooth muscle. Like this one, if you unable to differentiate, most of the time when we talk about smooth muscle, it is actually muscles that have cavity inside it, meaning it has some level, some sort of area within it, organ lah. Okay, we can say that the organ is actually part of our involuntary muscle, where most of the movement is not being controlled by our sympathetic system, but it is being controlled by our parasympathetic system, meaning that most of the work being done is actually autonomous, involuntary. Okay, that is skeletal muscle, right? So regardless of the type of the muscle, either it is a skeletal muscle, smooth muscle, or maybe the cardiac muscles, skeletal muscles are made up of fibers. Okay, if you take a look here, this is what we call as a group of muscle. So within the group of muscle, we have a smaller group where we are going to name it as fascicle. Okay, and within the fascicle, we have fibers. Okay, this is known as fibers, and within the fibers itself, we can come up with myofibra, where the most simple building block of it consists of two things, where it is consists of actin and also the myosin. Uh, and each of this group of muscle being wrapped up by a sheet of membrane known as epimysium, perimysium, and endomysium. So the whole group of muscle fiber being wrapped up by perimysium, and then the fascicle by epimysium. The group of muscle being wrapped up by epimysium, and then the fascicle by perimysium, and then the fiber itself being wrapped up by endomysium. So epi, peri, and endo, where this membrane provide the some sort of the stretchability of the muscle itself. Okay, so here it see that skeletal muscle are made up of muscle fiber bundled together. Each fiber can contract or relax on demand. So the one that actually move is actually the group of actin and myosin within one sarcomere of muscle fiber. So a lot of sarcomere will contact with one another, and when all of that undergo a contraction, we are going to see shortening of muscle. So all fiber contract together to shorten a muscle. The command contract or relax is given by the brain and relay to the muscle by nerve. So if we take a look here, this is actually our brain. This is the nucleus of the neuron. To be exact, this is the efferent neuron, where it originated at the brain, and the sensory end up at the muscle fiber. To be exact, it will activate motor unit. Okay, each motor unit will control a group of muscle fiber, or more or less. Okay, next one. If we talk about movement or articulating joint, okay, articulation, sendi, generally muscle move the skeleton by working in opposite pair. We have bicep, we have tricep, we have quadricep, we have hamstring, we have gastrocnemius, and also soleus. And at the head, we have flexor digitorum and extensor digitorum. We have the pectoralis at the front. We have the deltoid. We have the what we call the spine muscle and everything at the back, in order to ensure one muscle contract and another muscle will retract. So the end product, we are going to see articulating movement. This is what we call as muscle works by pairs. So for instance, if you try to bend your elbow, okay, you try to bend your elbow, your bicep at the front of the hand will actually contract, while the tricep at the back will relax. But if you try to straighten out the hand now, the works will actually turn over. The tricep will contract and the bicep will relax. So it works the other way if you try to straighten your arm. And in some joint, like the shoulder joint, many different muscles are attached. This allow even greater freedom of movement. For example, muscle dekat shoulder kita kan. So we have bicep attached there, tricep attaching to there, the deltoid attaching to there, the subscapularis attached to there. The pectoral is also attached to our shoulder girdle. More muscles, more stable, more movement, more power output. Okay, if we compare just by two muscles attaching to one another. So the act of locomotion is typified by a number of events which occur in rhythmic repetitive movement. Okay, a number a normal subject can change the speed, frequency of step to meet the need of the locomotion. And several motor tasks with core component but different frequencies are also applied to set up corresponding relation between the design task and the different type of locomotion in real cases. For example, dia bagi dekat sini, walking, running and jumping. So running and walking are integral to most sport, and there is a considerable amount of biomechanical analysis involved in examining the force produced by each of our foot contacting to the ground. Ni maksudnya, if we try to have movement, it will involve a set of instruction. Okay, like I said earlier, it will start with our sensory. For example, we see forward and we have the intention to move forward. When we have that, the sensory itself, let's say the sensory from the eyes, it will send signal to the brain through our afferent, and then the brain is going to do the computation and it say that okay, we move forward, and by that another set of instruction will be sent down through our descending pathway to the working muscle through efferent, where the endpoint of the efferent is actually motor unit that will activate our group of muscle. For example, it will activate our soleus, gastrocnemius, hamstring, and quadricep in order for us to locomote forward. When the motor unit being activated, muscle will start to contract. Those sarcomere will start to shorten up, and then it will pull our joint. For example, gastroc soleus will actually pull our what we call it, our ankle, and then the hamstring and quadricep will actually pull our thigh and the knee. So by pulling all those, we are going to see movement at the joint. To be exact, it will be our hip joint, our knee joint, our ankle joint, and we are going to see skeletal movement of our leg from straight. Now it become flex and then step forward. So this is actually a very organized and synchronized movement ataupun locomotion process. Okay. Now let's see the first one, walking. Okay. So normal walking locomotion is a term given to describe walking by individual who fall within the range considered normal. Okay, so how we define a normal walking? We are going to define it by using a gait cycle. So this is gait cycle. Okay, figure below provide a visual display of the event in the gait cycle ataupun the period which start the instant one foot contact the ground and proceed through the process of walking until the instant of the same foot again contact the ground. Okay, when we try to explain gait of walking, tengok dekat sini kita tak boleh tengok dua-dua kaki, we just take one kaki. Kita ambil kaki kanan. One gait one cycle of walking gait is when the leg, okay, leg ni kaki kanan, it move, it has a contact. This is the first contact, and then it move until it has another same contact. Ini kita panggil sebagai satu walking gait. Okay, so we have several movement in one walking gait. Example, let's see apa kita ada. Ni dia. Okay, the walking sequence consists of stance, pre-swing, and swing phase. 3 fasa. Stance is when our tumit has contact with the surface. That is our stance phase. Tak bergerak. Just contact from tumit with the ground. That is known as a stance phase. Then we are going to push our leg to the back. Okay. Bila kita push our leg to the back, kita dapat fasa yang ni lah. Tadi daripada kaki ke depan, now kaki ke belakang. This is known as pre-swing. Okay, kenapa nama dia pre-swing? Because after the end point of our pushback, we are going to start swing our leg forward. And during this process, the leg is not in touch with the ground. Satu nama dia swing. Pre-swing, Still, there are contact with ground. Stance is the process where it is a first contact. So contact, pre-swing contact, and then swing phase, no contact. Until another contact. So this is another cycle. So habis je contact lagi sekali, this is the beginning of another stance phase. So we have stance, pre-swing, swing, stance. Stance, pre-swing, swing, stance. Okay, in particular, the pre-swing phase is a transition phase in which the leg contact to the ground and the stance and swing leg exchange roll. Okay, apa yang exchanging roll? Okay, tengok kaki kanan dia. Stance phase, contact with the ground. When that happen, kaki kiri dia akan berada pada fasa swing. Maksudnya kaki kanan contact, kiri dia akan swing. Okay, kiri dia akan swing. So pre-swing is a phase where our right leg is in the point of last contact and our left leg already swing and contact. Maksudnya fasa pre-swing, kaki kanan dalam keadaan bersedia untuk goes airborne. Kaki kiri now dalam proses stance phase. Okay, dalam proses stance phase. And then when the kaki kanan start lift off, masuk kepada swing phase, kaki kiri berada dalam keadaan pre-swing. So maksudnya bila kita berjalan ni, setiap satu tapak, satu kaki akan ada contact. Bila dua-dua kaki ada contact, okay, itu ialah fasa stance. Kaki kanan, first contact. Kaki kiri, last contact. Okay, kaki kanan, first contact. Kaki kiri, last contact. And then bila kaki kanan being pushed back, that is pre-swing. Maksudnya dekat sini, antara stance dengan pre-swing phase to the left leg, that is swing phase. Okay, that is swing phase. Dia tak jejak. Sampai sini, kita akan ada stance phase. Untuk kaki kiri, untuk kaki kanan, pre-swing. So when the kaki kanan goes pre-swing, goes swing phase, kaki kiri is in the process of pushback. Okay. So maksudnya kalau kita buat lakaran kan, if we do some lakaran here, okay, this is stance. Okay, dekat sini. Ni, kita buat satu. Okay, this is actually stance phase untuk kaki kiri. Okay, stance phase untuk kaki kiri. Okay, kalau kita tengok kaki kanan, kanan ke kanan, kiri ke kiri. Okay, now kita letak kiri ke sini lah. SK. Stance phase for kaki kanan, pre-swing for kaki kanan. So we have stance phase for kaki kiri and then pre-swing for kaki kiri. Okay, pre-swing. And then kita ada swing phase untuk kaki kiri sampai another contact of kaki kiri. Dia akan masuk kepada pushback. Okay, this one is pushback. Sorry, sekejap. Mana saya punya undo. Wait, yeah. Here is it. Okay. Alright. So we have stance phase, pre-swing phase, swing phase. Ni kaki kanan Kaki kanan di depan, sampailah kaki kanan di depan. Maksudnya untuk kaki kiri, this is the starting of dia punya swing phase. Thus. Okay. Dekat mana dia punya pre-swing? Ni sampai sini, sorry. Ni dia. This one ialah fasa pre-swing kaki kiri. Okay. Ini ialah fasa stance. Okay. Stance phase kaki kiri. Kenapa kaki kanan punya pendek, kaki kiri punya panjang? Sebenarnya sama je, tapi yang ini dia tunjukkan kaki kanan dia dah cut short, nampak kaki kanan kat depan, kaki kanan kat belakang. Okay, bila kaki kanan kat belakang, permulaan pre-swing. Kaki kanan kat depan, starting stance phase. Sama dengan yang ni. Jadi kalau kita tengok yang ini ialah kaki kiri di belakang. Kaki kiri di belakang ialah pre-swing. Okay, sama macam ni, nampak. Kaki kiri di belakang pre-swing and then, dia akan ke depan. Yang ni dia masih dalam proses swing ke depan. This one is dia punya stance. Okay, this one is dia punya stance. So dekat belakang ni kita ada swing face untuk kaki kiri. Okay, swing face kaki kiri, it move forward. Ni kaki kiri, left. Kaki ni pula it move back. This one is right. Okay. So kita tengok kaki kanan dulu. Right leg pacak, go to the back, that is stand face, until the last point of contact, that is pre-swing. And then we are going to see the right leg start swinging forward. Ni swing face. When it goes forward, that is swing face. Sampai mana? Sampailah first pacak. To swing face. So untuk kaki kiri, kalau kita tengok dekat sini, the kaki kiri is at the back. Dia nak hayun ke depan. Bila hayun ke depan, that is fasa yang sama dengan ini. That is swing face. So it goes swing face sampailah first pacak. So the first pacak will be known as stand face for left leg. And then we have pull back, pull back, pull back until the last point. Ini ialah pre-swing. And then kaki tu akan mula ke hadapan balik. Masuk swing face untuk kaki kiri. And it continue with this picture again. So that is the process. We have first pacak, stand face at the front. And then we have pull back until the last contact. We are going to start pre-swing, where we are going to change direction from the back, from swing to the back to swing to front. And when the leg is airborne, that is the swing face. Until another pacak of 2 mate. Pacak 2 mate lagi sekali, itu ialah fasa stance face. So we have stance, pre-swing dengan swing face. So at the beginning of the pre-swing, the gastrocnemius, which is one of the target muscle of the calf, is stretched and finally shortened. So typical the swing face when walking is about 40%. Jadi ni fasa ni 40%, 40%. So stance and pre-swing is roughly 60% of our walking gait. If we compare walking and running, in running kita tak ada pre-swing, itu je. We don't have pre-swing because there are moments where both of the leg is actually airborne. Kalau kita tengok berjalan tadi, there are phase, dua-dua pacak nampak. Satu pacak depan nak angkat hayun ke depan, satu lagi pacak belakang dalam proses swing back. So we have pre-swing. This is known as pre-swing. The leg that we try to focus now at the end of drawing back. So contact at the fingers. And the another leg, the subsequent leg, is in the process of swing face, stance face, where to make pacak. So at this moment, at pre-swing, we can see that both our leg is have contact with the ground, but not in running gait. Running gait tak ada. Contoh kaki ni pacak, kita ada stance. And then bila pacak, it will start to pull back. Okay, dia pull back sampailah hujung kaki. And when habis hujung kaki, it start swing face. Mana pre-swing? Pre-swing tak ada because when the right leg start to change direction forward, the left leg baru dalam fasa nak pergi ke stance. Dia belum jejak lagi. And when kaki kiri dah masuk stance, kaki kanan dah dalam keadaan swing face. So we left one face, which is pre-swing. So in running, there is no pre-swing simply because of the timing of the movement itself. Running is defined as gait in which there is an aerial phase. Dia ada fasa aerial. A time when no limb are touching the ground. This are the phase ni. Antara fasa ini dengan fasa ini sikit ni. This is known as aerial phase. And this phase substitute the pre-swing. Okay. However, the running sequence consists of only the stance and swing phase. Unlike walking, there is no pre-swing. Instead, they are flying fish at the start and end of the swing fish, where there are no contact of the leg on the ground. Kalau kita berjalan, macam mana pun satu kaki mesti jejak dekat tanah in order to have our pull back. But in running, since it is fast, so there are time where both of our legs actually airborne. Cuma dia tak ada lagi terbang sebenarnya, but fasa tu kaki kiri, kaki kanan dah tolak, dah hayun ke depan, kaki kiri belum jejak lagi. So that is known as aerial fish or flying fish. But we are not going to include that in the running gait lah. Bila kita cerita running, aerial fish tak masuk. Okay, bila kita cerita gait, aerial fish tak masuk. We're just going to discuss about stance, pre-swing and swing. Okay, so in the running, upper body and lower body move in contrary direction, and almost all the muscle in lower extremity is used in running. And then if we compare swing phase of walking and swing phase of running, walking consists of roughly 40% of swing phase, but in running, the swing phase is roughly around 60% of the process. This will be the difference between walking and running gait. Yeah. So during running, the athlete's leg move forward quadricep muscle, bend the hip and straighten the knee. Ni yang saya masukkan dengan what we call it, like what we say, the move. When we talk about locomotion, it is actually involve a very intricate and complicated motion, and the motion will follow step by step. We cannot skip the motion, or else the gait itself is not going to be present. Okay, so during forward movement of hamstring, soleus and gastroc straighten the hip. Gluteal muscle help to extend the hip. Hip extender and hamstring muscle work together by extending the hip. And the final that we try to have is this one. The swing phase when running is about 60% of total gait cycle. Kalau kata walking tadi, swing phase only 40% because they have 30 stance, 30 pre and 40 swing. But in running, most of the phases is actually swing phase. Okay, this is the comparison of movement between walking and running. I want you to observe the pattern. Okay, don't observe the difference here, but I want you to observe the pattern. Okay, so kita ada stance, pre-swing, swing. Now we have stance and swing. If you take a look here, from stance to pre-swing, kita ada increment and then decrement. Tengok dekat bahagian running, sama je, kita ada increment of movement angle and then decrement. If we take a look at this tree and compare to the tree on the right side, we can see that the pattern is actually quite similar. Naik, turun, naik, turun, naik, turun, naik. Naik, turun, puncak dekat swing. Naik, turun, puncak dekat swing. Macam ni. The least one ialah bahagian stance. Same goes. Yang paling rendah dekat bahagian stance. So we can make a conclusion, say that walking and running, the pattern of our ankle, our knee, our hip is actually quite similar. The difference is just how fast it goes. Dia pergi tu lebih pantas. Dia pergi tu lebih pantas berbanding walking. But in terms of pattern, the pattern is equal. Dekat sini increment of angle, dekat sana pun increment of angle within the same phase. Okay, right. So another one, comparison between walking and running. If you talk about running and walking motion kinematics, comparing, okay, when we do comparison with the pre-swing phase of walking and middle to terminal start phase of running, this rotational direction of the ankle joint are identical. Macam saya cakap tadi lah, it is actually similar. Okay, it is actually similar. Walking and running are completely different gait modes kinematically and dynamically. The difference is just towards how fast it goes to kinematic dia. Okay, how fast it goes, how far it goes, cadence dia kan, berapa dia punya tapak and everything, that will be different. But in terms of the shape, it is actually similar. It will involve the same joint, it will involve the same type of movement, flexion, flexion, extension, extension, and the difference is just towards how fast the movement goes. Itu sahaja beza between walking dengan running. Okay. So for conclusion, in biomechanics, we always ask a question on how that we can do in order to enhance the performance. Okay, while at the same moment, we try to reduce injury. Why? Because injury always occurs because of overloading. Too much stress to the muscle, too much stress to the skeletal system and joint will end up injured. So we try to avoid that, and at the same moment, try to push the boundaries. So it is actually essential that we understand the force involved in producing athletic movement as well as the features of these forces. So by knowing the line of force, by knowing the directional of this force, we can actually reduce a lot of injuries. Okay, and knowledge in human locomotion, again, knowledge in human musculoskeletal system will actually help us to understand how far we can go, how fast we can go, how much stress our body can go before getting injured. If we can actually play around around that kind of level, we can actually have quite a powerful output and at the same moment less and less injured. So that's all for our uh, last topic in anatomical basis of human motion, where the focus is actually on the walking and running gait and the differences that we may have from those two different locomotion style. Okay, with that, thank you. Assalamualaikum and have a nice day to all.